Purpose of this meeting is to discuss the CSI Kubernetes implementation with regards to security implications for the design. In particular, we wanted to talk about the way that secrets would be handled, whether that would be similar to the way that secrets are currently handled for existing volume plugins. Jordan's been doing a massive effort to fix some of the existing entry volume plugins, and we want to make sure we don't make the same set of mistakes again. And then any other security considerations that we might have. So let's start with the secrets first. So CSI currently exposes basically three main hooks. One is to create a volume, one is to attach a volume, one is to mount a volume, and it allows credentials to be passed in on each one of those calls. And in addition to that, because the plugin is deployed externally, meaning it's a separate container or completely external to Kubernetes, the credentials that are required for the plugin to talk to the storage control plane can be deployed out of band. They don't need to go through the Kubernetes API. However you actually deploy your CSI driver, you are responsible for ensuring those credentials are available. So that would be, you can imagine a pod that has a secret injected into it that is acting as the volume plugin or the volume driver, the CSI volume driver. So because you have a mechanism by which you can inject the credentials required to talk to the control plane directly into the driver, that basically leaves only user-facing credentials or cluster administrator-facing credentials for the create, attach, and mount calls. For the attach and provision calls, the attach and create calls, the way that Jordan laid it out with saying that for the external provisioner and the external attacher, you must have a separate namespace, and the namespace can contain a secret. And for provisioning in your storage class, you add a parameter that has the namespace and the secret name. And since your external provisioner has access to that namespace, it can pull the secret. And then for the attacher in the CSI volume source, there would be an attach. Credential or attached secret that would allow specifying both namespace and the name of the secret. And since the external attacher would be limited to its own namespace, as long as the secret is available inside that namespace, everything is good. Now, both of those attach operations and provisioners are technically set up by the cluster administrator. So cluster administrator decides, I want to deploy this storage system on my cluster. I'm going to set up these namespaces, and I'm going to populate the credentials.
And are those controlled by storage class parameters?
The provisioner would be storage class parameter controlled, and the attach would be CSI volume source.
Okay, and is that a persistent volume source?
Right now, they're both the same, and then we can talk about splitting them out. So right now, both it's a persistent volume source and a volume source. It's just one object.
Okay, so the one inline on a pod. I apologize, I haven't kept up with the full design. Is it a separate object, or is it inlined in a pod and inlined in a PV?
Inlined in a pod, inlined in a PV.
Okay.
The same object inlined in pod and inlined in PV.
Okay.
So inside that object, there is the attach credentials, which is an object reference, which allows you to specify both namespace and secret. So up to that, I think it's uncontroversial. We're on the same page. Where it gets a little tricky is having mount credentials. So it's possible.
Before we get to mount, for attach, if you have an inline definition of a CSI volume in a pod, are you saying that that definition can reference an attached secret outside the pod's namespace?
Yes.
Okay.
So
Why is that okay?
uh, so the way that I imagine it working is, well, the way it is going to work is the CSI volume driver or the entry CSI component on attach is going to, it doesn't care whether you went through a PV or through a direct inline reference. It's going to create a new API object called volume attachment, and it's going to copy the volume source into that object. And that's a non-namespaced object. And then the external attachers are monitoring that object and acting off of it. So as far as the external attachers that are going to do the attaching are concerned, they have one non-namespaced object that they're looking at, which is the volume attachment object, and how it gets populated, they don't care about. So basically what happens is in both cases, Kubernetes will take the volume source and just copy it over into the attachment object. And then it is up to the external attacher to go and fetch that secret. And so if the external attacher has access, it doesn't matter whether it was inline or went through a PV, the external attacher doesn't care. It just needs to have access to that namespace.
Doesn't that let a pod author direct the attacher
It does.
to use credentials that are under the pod author's control? Like to telling it to go make use of attached credentials that the pod author shouldn't be able to point at.
The pod author can point at any credential that in the entire system. Mm-hmm. The assumption is that the external attacher, what it can access is limited to what it should be allowed to access. And
sure, but if the attacher is managing a set of things,
yep,
just because you're going to support this volume type,
yep,
in a bunch of different places,
yep,
doesn't mean that any pod should be able to use any attached credential, right?
This is where we need to. So you're right, and for both attachment and provisioning, we're not trying to prevent pod from accessing it. We're trying to say, does this do you have access to use this volume at all, or is this volume, should this volume be allowed to attach or not, or should this volume be allowed to provision or not? The actual control of whether a particular pod is allowed to use that volume or not should be the mount credentials, right? So if I want to limit access to a volume, what I do is I have to verify the credentials on the mount step, and those credentials are limited to the user's namespace, the pod's namespace. So even if a volume is attached, it's not actually going to be usable until it's finally mounted, right? So you break it up into these steps. There's create, there's, hey, there's Paul. There's create, there's attach, and then there's mount. And as far as a single pod, a single workload is concerned, it does not have access to that volume until the mount step is done. And the problem is that a single volume can be used by multiple workloads. So it could be true that one pod should have access to that volume and another pod should not have access to that volume. And so therefore, the ultimate decision about whether a pod has access or not must be made at the mount step. So now moving back from that, you have attach. I envision that most people will not want, there is not really a need to have credentials around attach. If they do, the credentials are for the volume level, basically just saying that this volume is allowed to attach to this node. That's it. It's not saying that this particular pod has access or not, if that makes sense.
Right, but I'm trying to think of places where we had attach credentials. Did Azure make use of attached credentials? I feel like it did.
I can't remember. If
maybe it was Mount. So presumably, if attach is protected by credentials,
Yep.
then that is to prevent a volume from being attached where it shouldn't, or to ensure that you have the ability to attach a volume. Attaching a volume can disrupt other users of that volume potentially, right? Like it might not go all the way to exposing the data into the pod.
Right, but it could denial of service.
Right.
Force you
It seems odd to put control of resources outside, allow targeting resources outside the namespace from within the namespace.
So the alternative is that basically you require the user to specify the credentials they would use. But the problem is that the way that attach happens, it's not guaranteed to happen for every workload. So if, for example, a pod got scheduled onto a node, and that pod should be allowed to attach to that node, and everything is good, it's going to attach, mount is going to happen, all is good. Another pod comes along and references the same volume, and that volume gets scheduled on assuming the same node, but that pod should not have access. So
right. I mean, the data model of like tying, having a shared volume. The data when you have a shared volume, the data model of defining that in a actual volume object like a PV makes more sense to me, because it gives you a coherent place. Like anytime I attach this volume, this is the secret I use to attach it. Having inlined definitions of the same volume in pods where they each get to specify a credential. I mean, if the inline definition can specify an attached credential, you already have the case where they can specify different ones, or ones that don't work but still reference the same underlying volume. Like I'm just trying to understand the data model.
Yeah. No, I can see that. Basically, what we're saying is that there are credentials around where a volume is allowed to attach. And if we let the end user control it through direct volume reference, then they could potentially point to a secret that they shouldn't have access to and attach the volume to a node where it shouldn't be, and they won't get access to it because technically there's mount credentials that should prevent access, but they are going to prevent, if it's a single, it's a non-shared volume, then though they could denial of service somebody else who wants to access it on a different machine.
Right. This becomes an issue when you have like one type of volume for which you have distinct, actual volume instances. You're like, these volume instances go here, these volume instances go there, and so you have different, different attached credentials for different sets of volumes. Is it also the case that all volumes will require mount credentials?
No.
Okay, so in the case where a particular volume didn't require mount credentials, attaching might actually be enough to actually get access to the volume.
But that, like in that case, if you don't have any credentials on your mount, then you basically are saying that you don't care about workload level authentication or authorization.
Or you want to control it via PVCs. So pods can't reference this directly. They have to go through a PVC, and that determines which PV they're going to get access to. Like you remove the pod's ability within the namespace to like reach out and be like, I want that volume.
Yeah, basically they need cluster admin privileges.
The other way around and say, no, we're going to give you this PV.
Yeah, I see your point. There's a couple ways around it. One would be to try and follow a model similar to what we did for the other volume plugins, which would be to split these credentials on PV, make it object reference, and then on direct volume reference, make it a local. That gets ugly and a little bit confusing. A crazy idea I have is, what if we make CSI volume source only accessible via PV?
That's actually what I was expecting. I thought we were trying to get away from inline volume definition.
We would like to.
Yeah.
The problem is there are people that are still using it, and I'm worried about the potential backward compatibility issues. For example, we do want to migrate the in-tree volume plugins eventually to CSI. And if we do that and there's no way to be able to directly inline, actually, no, that wouldn't matter because the interface from the old API would still apply. So I think I think we should be able to get away with it then. Let's do that. Let's, for alpha, say that CSI is not going to allow direct volume reference. Let's see what kind of hell that raises. And if it raises hell, then we can consider introducing inline with the split local reference model that we've been following for the entry volume plugins. So to state that more explicitly, we still have 3 sets of credentials, one for create, one for attach, and one for mount. Credentials for create will be passed through storage class parameters and will contain both the namespace and the secret name. But storage class objects are limited to, are non-namespace, so they require cluster admin credentials to be able to set them, so we're not concerned about that. Next up is the attached credentials. Attached credentials will also be a will allow you to reference both namespace and secret, and they will be exposed through the PV CSI volume source. Because PVs are limited to, or non-namespace, they should only be accessible by cluster administrator. In this meeting, we decided that we're not going to have a direct volume reference for CSI. That will eliminate the problem with users being able to point to an arbitrary credential. And then finally, we can talk about mount credentials, which, as I've spec'd them today, should only exist in the user's namespace. The pod namespace, sorry.
Okay. So so I have this straight in my head, create, who calls the CSI interface for create?
It would be the external provisioner.
Okay. And based on watching
PV objects, PVC objects.
PVC objects with a referencing a storage class that is that.
Correct.
Okay. And so that provisioner has to be able to look up the credentials referenced by the storage class parameters, which it can do. You can isolate it to a namespace and give it permission to do things in that namespace. So that's good. Similar for attach?
Yep.
Okay. So that is it watching PVs.
It's going to watch a new object called volume attachment.
Okay.
And volume attachment is also non-namespaced.
Okay.
It is going to be created by the Kubernetes kube controller manager.
Okay.
And the volume source is just going to be copied into it. So it's just going to copy over the reference into the attachment volume object and then volume attachment object. And then the external attacher will monitor these objects, and then it has to go and fetch the secret itself the same way the external provisioner does.
The provisioner watches PVCs and storage classes and creates PVs.
Right.
Kubernetes controller at the correct time creates volume attachment objects containing
information about which volume
information pulled from referencing the PV? So is it just a reference to the PV, or is it a copy?
Actually, just copying the volume source into the attachment object. That way, even if we lose the PV/PVC, the attachment object is whole and can be operated on without requiring the external attacher to have to go and fetch PVs and PVCs. It can just operate on volume attachment objects alone.
Is there a reason to denormalize that? Was it just for the
convenience
case
and
where the data is there if it gets deleted?
Yeah, basically.
It might be worth looking at doing that via a finalizer on a PV. So if you want to require it to be detached prior to deletion, I mean, anytime we denormalize, you have the potential for things to get out of sync.
Yes.
So if it was just for the deletion case, a finalizer might cover that, but that's a separate question.
Yeah.
Okay, so but in either case, whether it's in the PV or in a copy of some of the data into a volume attachment, that's created by the Kube Controller Manager, and would have the same namespace secret reference that was in the PV. Then the external provisioner watches either PVs or volume attachments, either way. Sorry, external attacher, you're right.
Yes.
And that has to have the ability to look up that secret. So are we saying the storage class parameters would contain, could contain namespace and name of an attached secret and namespace and name of
no, the storage class should only contain the namespace and name for the provision secret.
Okay.
The CSI volume source, which will be part of the PV object, should contain the attach secret.
And that is a secret that is created by the provisioner?
It is a secret that is out of band. It's not created by the provisioner. It's created by a cluster administrator.
And how does the provisioner know what to set in the PV for that secret when he creates it? That's why I was asking if that needed to be a parameter in the storage class that the provisioner just copies into the PV.
Point. I think that's a gap in CSI that we have right now.
Okay.
It does not have a mechanism by which you can return credentials from the create call for attach. I will look into filling that.
Okay. So either let the admin specify it in the storage class so that it can be copied into the PV.
Yep.
Or let the provisioner return optionally the attach secret so that that can be copied or placed into the PV.
Yes.
Okay. I mean, either of those seem reasonable, even both, I guess. And I guess if you support the create call returning the namespace and name, some can return that based on parameters in the storage class. Some can return that based on when they provision mount an attached secret they provision. So.
Yep.
Okay. All right. And then mount is called by the kubelet.
Mount is called by the kubelet.
Okay.
And mount is the final step to saying, okay, I am going to make this volume available inside the workload. Potentially, for some volume plugins, mount is the only step that is mount is the only step that's required. The other ones are all optional. So I think NFS doesn't require an attach, doesn't require a create, and the only step that's required is mount. And so the credentials here are the credentials that should be a way for the workload to say, I have permission to use this particular volume. For a pod to say, I have permission to use this volume. And therefore, the restriction is that it must be in the CSI volume source, it has to be in the user's namespace. in the pod's namespace, the secret for mount. But now I'm thinking through it, now that we eliminated inline volume references, what that means is that the PV object needs to be created with a reference. If it's in the PV object, that doesn't quite match.
So what's the flow? If I'm a user that wants some storage here, today I create a PVC and reference a storage class and create a pod that references that PVC.
Yep.
And stuff happens, and the PV gets provisioned from the storage class for me, opaque to me.
Right.
And the PV gets bound to the PVC,
Yep.
opaque to me, mostly opaque to me. And then the kubelet mounts that in. And so from a user perspective, the only visibility I have, modulo some of the API fixes we're doing to keep attached secrets out of
Yep.
my namespace. All the visibility I have is the PVC.
Yeah.
Is the intent of the mount secret to require proof of access?
Yes.
In addition to the PVC?
You have the pre-provisioned cases where you could provision a volume. But I guess in order to pre-provision, you need cluster admin privileges to create a PV anyway. So
Yeah.
maybe mount credentials aren't required.
Well, I mean, I think it depends on the volume type, right? So some volume systems require credentials at attach time, some require it at mount time.
Right.
For persistent storage, I thought the goal was to abstract that so that the user didn't have to manage that. Like the volume subsystem is managing that for them.
That is the goal. And I think it's, so I think what I was coming to realize is that it's not strictly necessary if we eliminated the direct volume reference, because what are we trying to protect? We're trying to protect a user from getting access to an arbitrary persistent volume.
Mm-hmm.
And if you're going through the dynamic provisioning workflow, then it's assumed that the provisioning has credentials that will prevent you from creating it, and that's your...
It's going to be creating them pre-bound, essentially.
Right. And the other workflow we want to protect is if the volume is pre-provisioned, someone shouldn't be able to get access to it who doesn't have the rights to it. Now, if the PV object has no credentials at all, if a malicious user comes along and says, I want to access this particular volume, they're going to need to create a PV object to be able to point to that volume.
A PVC object?
A PV object, right?
Like a volume that isn't represented in the Kubernetes.
Exactly.
Yeah.
Which they can't do, and so that's not an issue. But there's a third case, which is somebody created a PV object and they don't want necessarily anyone to be able to pick it up. Mm-hmm. If they try to protect it by setting a storage class on it or something, that's not really security, because anybody can create a PVC pointing to that storage class. So then what you need is like credentials at the pod level, not even at the PV level, that say I want to verify that you have access to this volume, if that makes sense. And that's not something that we have in our interface today.
I mean, you wouldn't want to even get to the pod level. You'd want to prevent it from binding.
Well,
right?
We can't, right? How do we?
Well, that's what you want. You want to cut it off. If you're creating a PV and you don't want random namespaces to be able to set up a PVC and be like, hey, yep, I want that one.
Yeah.
That's where we really want to cut it off.
So the way that's possible today is basically you create a PV that has a dangling pointer pointing to a PVC that doesn't yet exist, and then you go and create the PVC, and then completes the binding, and it never gets put into the pool of available PVs.
Yeah.
That's possible, but you have to know what you're doing in order to do that.
Yeah.
And
when PVCs and PVs were first set up, you actually couldn't specifying a PV name on a PVC wouldn't like reach out and grab it. It used to be a one-way thing, and then and that was my memory of it. And so when I saw someone saying, "Oh no, you can do it this way," I was like, what? No. It's really convenient, except when it's not what you want. I mean, if we want the ability to have basically floating PVs that are sitting there unbound, but also can't be grabbed by arbitrary PVCs, it seems like it would be worthwhile to focus on that requirement. Like you said, you can already sort of do that by like pointing them at dummy things, and then like later coming and attaching to the things you want. So then I do agree that that is pretty opaque. But if that's the control point we want, it might be worthwhile to have auto bind false option that is like, I want to pre-provision these and like represent them in the API, but I don't want them to be able to be picked up. Because like trying to do it later, like let them attach, let them bind, but then like at the mount point, you're like, oh no, we fail. Like, or you can like, I mean,
like the way that it happens today, you have the bidirectional pointer and you set it up with half a pointer, and then you bring up the other.
Yeah, but the controller like happily completes the other half and completes the other half from outside the namespace, which, like I said, wasn't how it originally behaved. Having the ability to opt out PVs of that, like let namespaces reach out to me.
You also need to be able to say, I want to opt out, but I want to like allow this namespace to use it, is what we really want.
Yeah. Okay. So I think it's worth exploring, like, what's the use case around that? Like, do you want to pre-provision it, but only let certain namespaces, only let these be used by certain namespaces? Then that might look like a namespace selector on a PV, which is like, I only auto bind within this set of namespaces. I think it's worth kind of asking, what are the use cases for that? And can we address those directly?
Yeah. So that I think we can address separately. I agree there is probably something we can do to improve the user experience there. But I think in Kubernetes, it may be possible that you don't necessarily need mount credentials because of the way that our API objects are structured. But realistically, there are volume systems that will have credentials on mount.
Yeah.
And so the next question is, where should we expose those, and what should that look like?
So, I mean, having attach secret and mount secret, because those are different phases. They could reasonably both exist and be different. Having both of those in the PV doesn't bother me.
And does it make sense to you to have the mount secret limited to the user's namespace or the pod's namespace?
I think for anything persistent volume related, you're trying to keep details of the underlying storage out of the user's namespace.
You're trying to the user's namespace.
Like their touch point to the persistent storage is the PVC.
Yeah, but then if that is the case, then kubelet will need to have access to the namespace that is being pointed to, which I think you mentioned there is a way to do that.
So today we give kubelets the ability to get secrets referenced from persistent volumes. And if the secrets referenced from a CSI persistent volume source were actually broken apart into like, this is needed for attach, this is needed for mount, then we could give kubelets access to just the mount secret, which is nice.
So I guess my only concern there was then that a malicious user could point to a secret in somebody else's namespace.
Malicious user doesn't have control over this if it's at the PV level. You're letting the provisioner spec out, here's what you need to attach, here's what you need to mount.
Yep.
And that
and it's all part of the PV object, and it should all be part of the a namespace that is controlled by the volume plugin.
does that work? So for create and attach, the volume plugin is going to go out and get the secrets. So,
correct.
So yeah, that works. For mount,
Kubelet does the fetching.
Kubelet fetches. Okay, so if Kubelet fetches and we authorize the kubelet based on what is contained in the PV, then and then kubelet passes the fetched secret to the CSI?
Correct.
Plugin on the kubelet. Okay, so that would let the CSI provisioner return a random namespace and name and say, this is the mount secret. And then once it trickles down to the kubelet gets it, and we say, well, you can get it because it's the mount secret, and then it hands it off to the provisioner.
Yep.
So that's
bad.
Well,
you have to assume that your volume plugin is something that you trust when you deploy it. It's going to require elevated privileges.
Yeah. Yeah, that might be acceptable. It's worth identifying, like, this is what this means. It means that if a provisioner specifies an arbitrary secret here, the kubelet will obtain that secret and pass it to the provisioner. I'm trying to think, the point at which you could compromise that is at the provisioner point, which is good, because the provisioner doesn't run on the same nodes as user workloads typically. Typically you have like a set of infrastructure nodes running your like controller manager and your high privilege controllers, and that runs on your infrastructure nodes. So that's good. So the provisioner is the point at which it indicates, here's the secret I want to go get to mount.
I wonder if there's a way we could eliminate it. The only way I could see would be to not put it in a place where the provisioner could control it, but that would mean it would not be part of the PV.
Yeah, I think having, like, making each object coherent when you look at it is good. So like when you look at a PV, having it spec'd out, like here's attach, here's mount, I think that's good generally.
Here's another crazy idea. PVs are about floating volumes, and the attached secrets that we have in there are already about adding credentials around making this attachable.
But each set of credentials is optional. Some don't require attach. Okay.
Optional. We today have a mechanism to set mount options, which I believe are at the pod layer, if I'm not mistaken.
At the volume source and the PV.
Is it in the PV?
I think so.
Types.go. But I was thinking if we make it a sister of a mount option, the mount secrets, that could...
that assumes a homogeneous mount secret for every volume that's produced by that provisioner.
Oh, actually, no, scratch that. Mount options are part of the PV spec too. So okay. That doesn't change anything. Okay, I guess that's...
Yeah, the PV spec is intermediated by the controller. Let's call it, is it? Does the provisioner create PVs directly?
Yes.
Okay. Yeah, I think trusting the provisioner to create this cluster level object.
Yeah.
I mean, that's I think that's probably okay.
Okay.
Um,
I'm fine with that. So it sounds like the change I'm going to make to the existing design is change one, get rid of the direct inline references to CSI volume source, and two, change the mount secret from a local object reference to just an object reference.
Hey, so real quick, kind of a foolish question. I think the 99% case here for attached secrets is around cloud, where you have like an admin secret that you don't want anybody else seeing for the attach detach.
Mm-hmm.
And it's not something that's unique per volume. It's just something that's going to come from the cloud provider.
Yeah.
So I'm glad you brought that up, Brad, because that's the use case that we don't have to worry about with CSI anymore. Because it used to be that the only way you could inject secrets for entry volume plugins was through the Kubernetes API, which meant credentials like this, which the end user or the cluster administrator shouldn't really have to worry about. They kind of have to worry about. Now what we do is the CSI volume driver itself is going to be deployed out of band, right? It's going to be something like a pod, a deployment set, daemon set, something that you deploy on your cluster. And you have the ability, while you do the deployment, you as the cluster administrator, to inject the secrets that it's going to require for all volumes directly into that container for the driver.
So they're not even referenced in the PVs.
Exactly. So
when that thing goes out to attach an Azure volume or a GCE volume or an AWS volume,
and finds the secret in a file or whatever it makes sense for that particular driver.
Yeah.
And so
you have to keep it updated in two places, or else have the CSI.
It's not two places. It's I mean, basically your Azure attacher or your AWS attacher has to be able to talk to AWS, and you manage its relationship with AWS separately.
Privately. Okay. Okay.
Yeah.
So it actually simplifies things a lot. And I think that was the big use case everybody had. Once we eliminate that, I think very few subsystems actually use credentials that are cluster admin facing or user facing.
Yeah. I mean, having the slots here is
nice.
Valuable.
Yeah.
But I think we will see less and less use of them.
All right, cool. That was super helpful, Jordan. Thank you very much. Feel free to.
One thing, instead of an object reference, I would actually use a secret reference.
Okay.
We're going towards. We started out with object reference, which has like 18 fields, and we use exactly 2 of them, and that we're trending away from that, just having unused fields in API objects. So secret reference is what the PV stuff is getting refactored to, and that has exactly name and namespace. So.
Sweet. Okay. That sounds good to me. Could you take a look at the design and after I send out an update later today and then LGTM it from the security perspective? You don't have to sign off on the whole thing. I'm going to have Tim look at it, but at least from the security perspective.
Yeah, and we should note on for the mount secret aspect, there would be an update to the node authorizer to allow kubelets to read mount secrets in PVs that they were responsible for.
This would be for the new CSI volume source?
Yep.
Okay, so part of the work for the CSI volume source will be to update the node authorizer to make sure that its mount secret is readable.
Yep. And if you're picking a name for the API object, I would call it CSI persistent volume source, just for coherence with the other ones that are specific to the persistent volume.
That was going to be my question.
Yeah, if we ever, I kind of have a hard time envisioning some of this inline, but if we ever did end up doing an inline version of this, we'd want to avoid having our names flipped and having to do like local CSI volume source or something crazy.
Very, very good point. Okay.
Yeah.
Cool. I will make those changes and we'll send them out later this afternoon.
All right.
Thank you very much. Do you have any other questions about CSI in general or anything like that?
I'm sure I do, but I'm pretty fresh. So.
All right. I'm going to be out for a week and a half, but feel free to ping any of these guys. Vlad here is going to be working on the entry volume plugin.
This isn't related to the CSI stuff. Just on the Scale.io poll, there was one defaulting API
I sent a reply.
Okay,
Yeah, I
cool.
sent a reply. Okay, yeah. We'll talk offline.
All right, sounds good.
All right, thanks.
All right, thanks, Jordan.
Yep, bye.
Okay.
Thanks, guys. Bye.